So what are some of the biggest mistakes gate preparation students make?
calculation and units,
Okay, one is calculation and units. Other mistakes,
Unit conversions.
not enough practice. Yeah, no fair points, but I think Prince kinda read my mind. The two answers I had in for today's agenda. First thing is to take care of your health. Okay, only if this is fine, then all else follows. And calculation mistakes, right? This is where typically silly mistakes happen. This is avoidable. Silly mistakes, right? So this is avoidable. Not enough practice, right? This is also actually very true. And for today, I'm going to add a couple of connecting words to it with gate calculator. Okay. Yeah. Then of course, time management, lack of planning. We have so many other things. Then yeah, not revising is towards the end, near the end, revision becomes extremely important. Okay, so today, we want to get started with this thing, that is this guilt calculator. Okay, so from now onwards, everyone, for all practice, all class, class problems, mock tests, general practice, I suggest you switch to gate calculator. Part of today's class is to actually tell you gate calculator is very easy and very convenient once you get a hang of it. And today's objective is also to get a hang of it. So let's get started with that. Okay. So notice, so the moment you get used to doing this kind of expression, then it's all, you know, things kind of like, this is where you start getting a hang for the gate calculator. Oh no, all this, I don't have to write down what is e square in the paper. I don't have to write down what is log 6 to the base 5 in the paper. Then I don't have to write the numerator in the paper, denominator in the paper separately and all that. Then finally do things. That is when you realize actually this is in ways better than your normal calculator. So many of us are used to writing intermediate steps in paper, right? You can avoid that. That is a major advantage of this. And then the moment you know how to use it, and get some familiarity with it, things are easy. And doing this expression would be like a starting point for that, getting some familiarity. So just go to Google, type gate calculator. I think the first link will take you to this. And first part, let's all get interactive. Okay. You can also share this link to you in the chat. Okay. So this is the calculator. This exactly looks like a gate calculator and all that. Here, let's do a series of experiments. Okay. So first thing I want everyone to do is open the link, try to find 1 over log 2. 1 by log 2. And also post your answers in the group so that we kind of know where you are. One over log 2, 3.32. Right. Okay, 3 answers. So let's see. Let's see. Let's get answers from as many as possible. Even if it's 3.32, if you get it from the gate calculator, post it in the group. Okay. So most of you got it. Others, I suppose, are kind of struggling. Right. Well, this is like, just log 2 calculation. There's like almost no excuse for you to not find, find and post this in the chat. Link is also a share. So the first thing that happens here is go press log, something like that. Okay, say, okay, 1 by log the moment you get, 1 by log 1 is 0, and then put equals infinity, you keep on getting absurd results even before you could, see the answer. 1 by log 2, right? It becomes 1 by 2 or something like that. So first thing is, this interface is not similar to our scientific calculator. That's a point that I want to make. Those who got it, fine. You can see the change in interface. Those who did not post, 3.3 to something, something that goes with that log 2 right now, right? This gate calculator interface is, I suppose, is very new to you. So that is fine, but at least we'll learn how to use this. There are some simple details as well as some, some involved details that we want to look at. Okay, first thing, what are all the things that you could see in this calculator? Let's get a quick list. And, if someone already posted something in the chat, avoid that. Try to add something new. What are all the things that you could see here in this calculator? What operations, what can you do with this calculator? What can one do with this calc? This is just to, again, to get general awareness of, again, where the buttons are and things like that. What are all there? I know students who go to the exam, are stuck with finding 1 over log 2, or trying to find where the square root is in this big list of symbols. So first thing is, we need awareness of where things are. And towards that, quickly, tell me what are the things you could see. Okay, we see numbers here. Let me get started with that. Okay, there is a equal to thing. Then there are some basic math operations, division, multiplication, addition, subtraction, addition. Then there is like subtraction, addition. There is one more button, C, probably for clear. There's some back or delete or something like that. Then we have square root, percentage, and 1 over x, right? Yeah, let's at least build on top of that list. We have sine, cos, and all that. We have all the trigonometric functions here. Okay. Then we have, say, okay, powers, radicals and powers. We have all of them here. And then we have all the logarithms, exponentials, even some constants over here, pi, e, n factorial is there. Then hyperbolic, sine, cosine, all of them. Then we have something called mod here. Yeah, sine inverse. All the trigonometric are here. Pretty much all the powers, logarithms are over here. Couple of constants, important constants. Then we have some degree, radians, probably to say, something is a degree, something is a radian, and all that. We have mod and percentage. So interestingly, we also have a percentage button here. Notice that. Okay, this mod, it's, this remainder thing. Then as Dinesh pointed out, we also have some interesting memory buttons over here. This memory buttons is what, any complicated expression, if you are unable to do this in the gate calculator, it means you don't know how to use this memory expressions. Okay, I suppose at least you all started noting what is there in this thing. Okay, so the first thing I want you to do is to find 4 plus root 4. Let's all do. Where is the chart? 4 plus root 4. Can you all try that right now? Nandini got a 6. How about others? All of you are getting a 6. Fine. Okay, 4 plus root. Notice you get, okay, 4 plus root 4 is this. Can you all do 4 plus root 2? 4 plus, I'm not getting for root. Root is over here, first thing. So the moment it says 4 plus root, actually it is not allowing to type, 4. Okay, it says, okay, let's all do 4 plus root 2 to highlight one issue here. Four plus root 2. Yeah, if you are getting 5.4 on 4, again, that is good. But if you are not getting 5.4 on 4, essentially 4 plus 1.4 on 4, this is notice things are tricky. Okay. The first thing is, yeah, if those who are not getting will go ahead and figure that out. The point is to highlight that this is not that simple of an interface. Okay. Okay. So first thing to realize is this calculator is based on the functional format. If you want to find logarithm of 2, okay, in a normal calculator, you plus log and then press 2. Okay. You have to do things the other way around. Okay. You have to first enter the number that you're trying to find, apply some mathematical operation to, then apply the function, say log. You get this. Okay. Say you want to find root, first type 2. Okay. This displays whatever is being typed in. Then we have the root in this, in this rightmost column, square root. You get 1.414. Okay, so that is the major thing. So for example, if you want to do 4 plus root 2, okay, you did 4 plus. Then you want to do root 2, first type 2, then do root of that. Okay, and what is being displayed here is currently square root of 2. If you press equals, you get 5.414. Okay, let's go one at a time. Madhuravani, are you able to do 4 plus square root of 2 right now? You do.
Yes, sir.
Okay.
Yes, sir.
Something simple. 4 plus first enter 2, then press square root of 2. And you are not seeing the answer yet because you need to press equal. Okay, Uma, are you getting this right now? Okay, Madhuravani got it. So the first point is this calculator is, the format of this calculator is extremely, or significantly different from what we are used to in the normal calculators. This is a major thing that, causes confusion among students. Why am I, I'm trying to do square root of 2, I am not able to do it. Why is that? Because, the order of operations, order in which you have to enter the buttons are very different here. That's the first thing you have to notice and get used to. Okay, next, let's do a sequence of things. Let me see if I have the things over here. Fine. Next, I want everyone to try this. Okay, I have a sequence of things. Let's go one at a time. Sine 30. So sine 30, by now, at least we will start avoiding this temptation, sine of 30, we'll avoid that. So 30, and then we go do sine, we got 0.5. Excellent, pretty straightforward, right? Fine, fine. Next, let's do sine pi by 6. Sine pi by 6. So pi by 6, we have pi, house by 6. Okay, and then sine of that, sine is sine pi by 6, and this, of course, this is incorrect, right? What is sine pi by 6? What is going on here is, notice what we are calculating is sine d, that is sine with degrees as input. Pi by 6 is a radians, right? Pi is like number of rotations, 2 pi is one full rotation. So you have this option to toggle between degree and radians. Okay, so first thing is find pi by 2. Okay, So this number is in radians. You want to calculate sine according to that. So I went to this radian mode and then do sine. Now I have sine r that says calculated, treating input as radians. And sine r, I suppose, is sine pi by 6. Is that 1? Or I did pi by 2, I suppose. 1 second. So pi by 6 equals this. And then sine of that is 0.5. Okay. So this often we'll be dealing with trigonometrics, and you want to know whether we are dealing with degrees or radians. There is a simple toggle to say whether we are finding, sine 30 degrees or sine pi by 6. Suppose this is clear. Now let's get back to my example and continue with this. So let's do sine minus 30.
Sir, it's in radian. Can you indicate?
Yeah, 1 second. So 30 minus 30. But notice we are not doing sine of minus 30. We are doing minus sine 30. For example, it doesn't always apply, right? Say, then for in case of sine minus x is minus sine x. Can you do sine of minus 30 here? Answer is 0.5, but we are not doing that. It so happens that that property kind of saves us. For example, so let's do 10 power minus 3. So we have minus 3, then 10 power of that. Yeah, see, now we are into trouble. Minus 3, 10 power of that, we get 1000. Why is that? Which is what I said, we are not doing sine of minus 30, we were doing minus sine 30. Can you all do, any one of you do 10 power minus 3 here? Mega got it. Mega, how did you do this?
So minus 3 first, then 10 power that value.
Okay, minus 3. Oh, you pressed equal
Yes,
and then
sir.
10 power
Yes,
of that. Okay. So notice, yeah, if you press equals, only then that number changes. If you do minus 3, we still have a 3. It's trying to do 0 minus 3. At that time, if you press 10 power, you get that. Okay. That is one way to do it. Or press equals, you get minus 3. Then do 10 power of x. That is possible. Or there is one more way to do it. Okay. Take a bracket to say you are doing minus 3. Okay. So now what is inside the bracket is minus 3. Do power of that. So bracket is in general works, always works. When in doubt, always use brackets. So remember this term. When in doubt, use brackets. Okay. But at the same time, you could also do this in a couple of other ways. That is just doing minus 3 equal. So we have minus 3 here in this typing box, and then do 10 power of that, we get that answer. There is one more way to do that. Okay. You type in 3 and you do this plus or minus thing. Its purpose is to actually change the sign. Let me show it to you again. We entered 3. We want minus 3. So press this button. It changes to minus 3. Then do 10 power minus 3. You get your answer. So that is why we have like a minus plus, and then there is a plus minus. So it is a converter, sign converter. Okay, fine. Then let's get back to our list. Let's do sine pi by 6 plus pi by 4. So, okay, toggle mode. I went to radians. Sine pi by 6 plus pi by 4. So we have pi by 6 plus pi by 4. Then sine of that. I hope this is Correct. So in this sine, is everyone getting the same answer? Sine pi by 6, 0.96. Nandini is getting that. Fine. Fine. So now kind of we got used to it. Again, just in case, you were wondering, you could always do, open a bracket, do pi by 6. Okay. And then plus, what is that? Pi by 4. Okay. Close the bracket. You have whatever some number, then do sine of that, you should get it. Okay, fine. Next thing is, let's do log of 3. So we know 3 of log, we get this. Okay, nothing magical about it. Let's do log 3 in base 2. So that also we have noticed there is a log x to the base 2 here, so that we can easily do. Okay, so this is log of 3 in base 2. Suppose we got the same answer, right? So 3 log of 2 in base 2, 1.58. Okay, again, because there is a base 2 logarithm that kind of saved us. There is a ln, okay, if you want in base e. There is a log in if you want answer in base 10. Interestingly, there is also a general base y. The way to use 2 input functions. So this has 2 inputs. X is, one of the inputs that we are trying to take the log. Then there is a parameter that we need to specify. So let's all try log 4 to the base 3. The last term there, log 4 to the base 3. (1.6). Fine. I suppose this is straightforward, right? So the way 2 input variables work is, okay, press 4, then press this, then it will actually ask you for what the base is. Still waiting for one more thing, just specify 3, then press enter, you should get that. Okay, this is also pretty straightforward. Okay, fine. So let's quickly see if all of us can do this. Let me post one more expression in the chat. So 90 degrees minus tan inverse 1 by 2 minus tan inverse of 1 by 4. Oops, sent it to one of you. So let's quickly do this expression. 90 degree minus tan inverse 1 by 2 minus tan inverse 1 by 4. So first thing is, we are talking about degrees. So my toggle is in rads. So convert that to degrees and then do, there is a tan inverse here. So shouldn't be an issue. Okay, we got one answer. Let me also try 90 minus, then we need to do, when in doubt, always do a bracket. Okay, so 1 by 2. And so once you type whatever things in the bracket, now the bracket value is 0.5. Let's do tan inverse there. Okay, and then again we want to do minus. Yeah, we will have 1 by 4 we have to calculate, and we don't want to interfere with this thing. So open a bracket. We want to calculate a function of 1 by 4. So close the bracket. We got 0.25. Do tan inverse. Okay, and value you are seeing right now is tan inverse of 1 by 4. To get the whole thing expression, press equal. Yeah, see, the previous expression was tan inverse 1 by 4. Only if you press equal, this will be shown. Once that is shown, how many times you press equals, that will still, this expression is what you are going to see. See, 1 point, let me quickly show where that 1.4 is coming from, 90. So minus 1 by 2. So 90 minus, at this stage, let me quickly 0.5 tan inverse of that minus 1 by 4. Okay, tan inverse of that. At this stage, what we have is in the answer here is tan inverse of 1 by 4. So if you press equal, you get the answer. Yeah, 49.3. Yes. Yeah, the answer for that expression. Okay, now let's slightly step up the gear. Okay, let's try something slightly complicated. And this is where, any expression like this, you certainly need to start using brackets. Okay. So 2e square 4 times log 6 to the base 5, all of them in the numerator. And then in the denominator, we have by root 3 into tan 37. Let's say that is in degrees, tan 37 degrees. How do we do this? So 2 into e square. Okay, e is there, square of that. Okay, we got 2 into square of that into 4. Okay, we got that into log 6 to the base 5. Notice here it's highly advised that you do a bracket, because you have to enter two numbers, right? You have to enter 6 and then a parameter 5. So to avoid any ambiguities, open a bracket, do log log x to the base 5, and then enter the base 5. Close the bracket. Numerator is done. Then denominator, okay, we have a by term here, by. Just be careful to open a bracket, because there are two terms, more than one term in the denominator. So I open a bracket. First term is 3. So 3 square root. Square root, no, all the powers are here. Square root is somewhere over here. I know of students who are like in this thing, where is root? Where is root? Remember, the basic numbers operations are in the right hand side. So do square root. Got square root of 3, and that times tan 37. Things are in degrees. Do 37, and then finally a tan. Okay, and to close the bracket, to find the actual answer, close the bracket. Okay, this is the expression in the denominator. To find the actual answer, press equals. Swarnendu has 2.7. I have some other number. Come on. Type in your answers. So I'll also do this again. So I have 50.4. 88.4. 27.49. See, this is exactly this gate 1.58. See, Vaishnavi, I think 1.58. Okay, things are grossly wrong. Okay, now everyone follow along. One of you have a scientific calculator, Sparnendu?
Yes, sir.
Can you do this in a scientific calculator just to make sure if
Yes, sir, sure.
50.4 is correct? Rest all of you, let's do it, repeat it with me. Okay, follow how I am doing this. Okay, so this is the expression we want to find. First thing is 2. Okay, into e square. So we have e here. Okay, and then do square. that is this square. I got square of E. Then do into 4. Again, that is simple. Okay, E square should be given as 2 and then E power x. You could do that. There are two ways to do it. 2 E power x, or put E and then do x square. Both should give you the correct answer. Okay, and then into, now see this log 6 to the base by, better open a bracket. Okay, 6, then log x to the base y, then specify the base. Okay, then close the bracket. Okay, then so we have finished the numerator by, okay, open a bracket, and that is 3 square root into tan 37 tan, close the bracket, equals, I still get 50.4. Others, and the scientific calculator result, yeah, 50.42 sounds. See, if you're not getting 50.42, we'll do this once or twice, because once you get kind of used to this such expression, you'll be fine. Okay, so denominator should be better visible now. So partly, in fact, don't rely on what you see here, rely on what you press. Don't learn to, so this is a tip that is going to help us further down the line. Don't look at the expressions or try to get the correct answer without looking at the first box. That expression shouldn't be really, what you should be bothered about. You should be bothered about typing the correct things here. There is a reason to do that. So don't rely on, whether you can see the numerator, denominator. Don't rely on that. Rely on typing the things correctly. And when in doubt, use brackets to be safe. Okay, anyone got 50.42? Okay, Nandini, excellent. So we have a first icebreaker. Okay, Spernendo, scientific calculator. Okay, scientific calculator, or otherwise, I suppose. Others, 5.42. Bhaskara is, I suppose it's 50.42, right? You missed a 0. Okay, so that should be the last one. Okay, so many of you got it. Okay, so notice, so the moment you get used to doing this kind of expression, then it's all, things kind of like, this is where you start getting a hang for the gate calculator. Oh no, all this, I don't have to write down what is E square in the paper. I don't have to write down what is log 6 to the base 5 in the paper. Then I don't have to write the numerator in the paper, denominator in the paper separately and all that. Then finally do things. That is when you realize actually this is in ways better than your normal calculator. So many of us are, used to writing intermediate steps in paper, right? You can avoid that. That is a major advantage of this. And then, the moment you know how to use it, and get some familiarity with it, things are easy. And doing this expression would be like a starting point for that, getting some familiarity. Okay, now, but if we stop here, we'll be actually missing what the calculator has to really offer us. Because the most important things that the calculator offers us are there in this 5 buttons: MC, MR, MS, M plus, M minus. Okay, so these are again very, very simple once we know what they are. So quickly, let's finish this, this gate calculator thing with doing a learning what these memory functions are. All other functions are simple. Okay, mod, quickly see, mod is, reminder 8, mod 3, right? Yeah, 3 divide by 8 by 6, reminders 2. So mod is reminder, degree, radians, all the hyperbolics, there is n factorial, trigonometric functions, exponential, bracket, logarithm, radicals, the normal numbers, addition, subtraction, multiplication, division. Percentage is also here, notice. So what is 3% of 75? 75% 3, right? So 2.25. You don't have to do that, 75 into 3 by 100. Okay, 75 into 3 by 100. You don't have to do this because percentage is there for you. 75%, 3% of that. So percent 3. 3% 75, 7%, I mean, 73% of 75, 75% of 3, both are one and the same. So whether you do 7% 3 or 3% 75, should give you the same answer. So that is there. Square root is here, 1 over x is here, just in case, there is a very, very big term in the denominator. You calculate that, 1 by 2 pi RC frequency, you do it 2 pi RC, just do 1 over that here, 1 over that quickly here. Then powers of 10, be careful. So don't do -3, 10 power. Okay, that is a typical thing. We'll be using 10 power x often. Do either, there are a couple of ways to do this, as I said. 3, change its sign, then do 10 power -3. That is simple. Or, uh, you're in a stress, forget things, use a bracket. So -3 bracket. Okay, and the bracket expression is -3, 10 power -3 of that. Okay, great. Now let's go ahead and do this memory functions. For that, I'm going to input another interesting expression. This to highlight what we have, what this thing has in store for us. Okay, suppose we can read what this expression is, right? So we want e power of, so there is a big bracket in the power of e. So we have 2 minus root 2 cube of that. So 2 minus root 2 cube plus 2 minus root 2. So often, this is just to highlight, get us started with memory functions. This is not all that useful for gate, but this is the starting point of using memory functions. The idea is there are terms that repeat often. Can we put that in the memory? We don't have to type 2 minus root 2 twice, thrice, 4 times, do the same calculation again and again. Say there are 10 terms here, 2 minus root 2 power 1, 10 minus 2 minus root 2 power 2, 2 minus root 2 power 3, so on, 2 minus root 2 power 10, right? We don't want to, each term you don't want to type in 2 minus root 2 again and again. So there is a way to save that. So quickly do that. So first of all, always, start with a clean slate, start with 0 here, 2 minus root 2, I suppose, let's do a bracket just in case. Okay, 2 minus root 2. Okay, I got this, right? Yeah, 2 minus root 2, right now notice is 0.5857. Can quickly save this in the memory. Okay, so ms is to save that in the memory. Memory save, ms for memory save. Okay, just do memory save and you get a signal here saying that things have been saved in the memory. That's it. Okay, now we could go do, this expression to calculate that, you can clear it. Anything saved in the memory can be read using memory read or MR. MR, you just got that. You don't have to type in 2 minus root 2 each time. Okay, let me show that again. The 2 minus root 2 is stored in the memory. Whatever is in the memory, there can be only one term in the memory at any point. To read that, just do MR. Got that. Okay, now how do we use this for this expression? Simple. So 2 minus root 2 power 3. So read this number, power of 3. Okay, plus 2 minus root 2 plus read the memory. That's it, equals. So we got the whole thing in the bracket there. Notice how quickly we got it. Okay. And then do e power So we already have the number here. I suppose we have pressed a equal to, already have the number, we can do e power x. 2.1. Okay, something very, very simple. So to save something to memory, ms, to read from something from memory, mr. So any expression that repeats again and again, you can save it in memory. So that's how this combination works. So let me also do this one more time. Okay, 2 minus root 2 power cube. What is there in the memory? This is 2 minus root 2. We have saved it. If you don't know what that is, okay, it's a good idea to clear whatever is there in the memory. There is something in the memory. You don't know what it is. Clear it. Start with a clean slate. Memory is removed. Okay. So 2 minus root 2. 2 minus root 2. Okay. 0.58. Okay, fine. Now I want to put this in the memory, save it. Okay, there is something in the memory. Now clear things in this display. Then you want to do this, read that. So 2 minus root 2 power cube, read from memory, cube of that. Okay, then again 2 minus root 2. 2 minus root 2. We just read from the memory, mr. Okay, so we got the all the terms in the power of e. Now to do e power this thing, so we need this number first and then we do e power x, right? So we already got that number there, fine. Now just go do e power of that. E power of that, 2.16. Again, another place where you can see this calculator is actually helping you. This is, this simple memory operations, right? 2 minus root 2, just in case, this, you really appreciate it if it's like, a GP 2 minus root 2 or arithmetic, not arithmetic, geometric progression with A is 2 minus root 2, R is 2 minus root 2. Find the sum of 10 terms, right? So you could appreciate that. For example, read from memory, that plus read from memory, square of that, okay, plus read from memory, cube of that, and so on and so forth. You could do, other powers, you could use brackets and do this. Fine. But this is often not that useful. Save and, remember is not that useful. What is really useful is this other two buttons over here, m plus and m minus. Okay. So first thing, again, after the end of each problem, clear the memory. That's a good habit. MC for clearing the memory. Yeah, the memory disappeared. Fine. Now let's do something very, very simple. 3 plus 3 plus 3. Okay. That is, we want to do a summation. That is where this m plus m minus helps. 3 plus 3 plus 3 is simple. We can do it this way. 3 plus 3 plus 3, right? 9. We can do it this way. But say each term is like a nasty expression. Each term is like this e power something. One term is this, one term is this, right? In that case, it helps to calculate one term at a time. Okay. And keep on adding things to the memory. That is, let's say 3. Okay. This is there in the total sum. First term in the total sum. Somehow we got it. Some expression we got 3. We don't know like what expression. We'll go to that next. Okay. We know this is there in the sum. So just do m plus. Okay. So the first term will go to the sum. Then clear things. Do the second calculation. So in this calculation, again, we are getting a 3. Okay. We can do lots of calculations here. By 6, 9 and all that. All that doesn't matter. At the end of the day, the calculation, the answer is 3. Okay. And you got 3, the second term. Send that to memory. Add that to the memory, m plus. Okay. Clear. And then some other lengthy calculation, 54, so and so, so and so, clear, do. At the end of the day, you get 3. That also goes to the sum. Do m plus again. That's it. Okay. Now, if you read what is there in the memory, you get a 9. So this, oh, you might wonder why 3 plus 3 plus 3 using m plus m plus m plus. It need not be 3 plus 3 plus 3. One of them could be this term, another could be this term. So find each term, add it to whatever is there in the memory. Okay. You have to be careful about one detail using here. Notice you are working with blindly with some number in the memory, right? You are not seeing what is there in the display. So which is why I initially said don't get used to what is there in the display. Get used to just typing properly. Okay. Because this function is very useful. And while doing so, let me also highlight the common mistake before we actually do a meaningful calculation here. So first thing is always clear a memory. You want to do 3 plus 3 plus 3, 3, memory plus 3, memory plus 3, memory plus. Okay. You read memory, you get 18 because you didn't start with a clear memory. Always do memory clear before doing any new fresh memory operations, likely at the end of each problem. Okay, now memory is clear, you do 3. Okay, memory plus 3, memory plus 3, memory plus. Okay, now you do MR, you get C. One of the problems that can happen here is, so let's clear the memory, let's also get rid of this 3. You have to press this M plus only once. If you press it twice, whatever is here will get added twice. If you press it thrice, whatever is here will get added thrice. Okay. Typically, we want to add only once. So once, press once, you are done. Press one more time by mistake. Okay. You read it. Surprisingly, you find starting with 0, you adding 3, you get 6. Right. So you have to be careful about this. Okay. With that, let me give you a proper quickly to see where this is useful. Quick expression. Suppose square root of 1 square plus 2 square plus 3 square. Okay. First clear memory. 1 square, 1 square. Okay. Send it to memory. 2 square, 2 square. Send it to memory. 3 square. Send it to memory. Okay. Read what is there in the memory. It is 1 plus 4 plus 9, that is 14. Square root of that is this. So notice typically dealing with series, summations, regression and all that, we'll have to do summation multiple times. That is where this memory is extremely useful. Mean square error, RMS, typically we'll have to come across this function a lot. Okay. So let's all quickly slightly change this and do, let's do 4 square plus 5 square plus 6 square. 4 square plus 5 cube plus 6 power 4. Just to see how this works. And square root of it, everything. Let's quickly see if you are able to get this. You don't have to necessarily use a memory for this, but if you get used to it, it's going to be simple. I'll also show one more example based on that, where memory, you'll really see that is extremely useful. That is 7.91. I have to actually calculate it. So let's just wait for a few more things. First thing is I have something in the memory, clear it. 4 square. So 4 square is there, good. Add it to memory. Clear the thing. Then I have to 5 cube. So 5 power 3. 5 cube, I have things here. So I'll just do 5 cube. add it to memory, clear. Then I have to 6 power 4. Power 4 is not there, so I have to do 6 power 4. So 6, this thing, power 4. It is 1296. Add it to memory, clear. Now read whatever is there in the memory, square root of that, 37.90. Great. At this point, you could say, I can easily do, I don't need the memory here. I can do 4 square plus 5 cube plus 6 4. Yeah, that is fine. I'll show you one more expression where that is not possible. And quickly, so this is m plus whatever term it adds to the memory, starting with 0. That is with the clear memory is 0. What is this m minus doing? Say, you want to do something like this. Same expression. One second. This expression, let's say you want to do minus 6 power 4. The first two terms you want to answer, add. The last term you want to like subtract. Then, okay, this is the complex numbers are not there. So let me quickly do, no, the second term you want to subtract. Let's say this is the expression that you want to find. 4 square minus 5 cube plus 6 power 4. Okay. That is where this m minus shows up. So again, 4 square, we calculated it. Okay. Send it to memory. Fine. Clear things. 5 cube. Don't do minus 5 cube. Just do 5 cube. 5 cube of it. 125. Whatever is in the memory, subtract this. So do m minus once, and then that's it. And then do 6 power 4. So 6 power 4. Okay. Then 6 power 4 needs to be added. So m plus. M rate, square root of that is this 34.4. Okay. So to finish this, let's do this expression. I don't know how well it's going to show up. Fine, it shows up reasonably well. Yeah, we want to do that long expression. All of you are welcome to try it. But let me also start doing this. I'm going to use a memory method. No, each term is like some kind of nasty expression, and I'm not going to store some intermediate and all 2 minus root and all. I'm not going to store. I'm going to store each term in the sum. So find this, add it to the memory, then find this, add it to the memory, then find ln 6, subtract it from the memory, then find 3 into 2 power 4, add it to the memory, then find 2 into log 6 to the base pi, subtract it from the memory. Okay, let's do this. Let's see who gets it right. Clear memory, clear memory, clear memory. Okay, clear display. So 2 minus root 2. 2 minus 2 root. I got this number. So 2 minus root 2, I suppose is 0.58. Cube of that. I got that. And then we have to do e power of that. So e power this number. So notice this is power of e, whatever this 2 minus root 2 cube. Okay, I found the first term. Let me add it to the memory. I added it once. I knew it. I added it. I pressed this button. So I'm going to clear. That's it. Then tan inverse of half. So half, 1 by 2. This way you can make mistakes in the intermediate steps. Right? 1 by 2, you enter 1 by 4, just do clear and do 1 by 4. This is like, there is a, in Tamil movie, there is a Parota comedy. Like, I don't know. So I don't know if there is an equivalent version in English or these things. So you don't want to start over again. Like, say you decide to say write a say spell something. Say you are in school, kindergarten, something like this, spell some tough word 100 times, your teacher gives you that punishment. Then you are counting it, you said it, and then you count 100, said go tell your teacher. Your teacher doesn't agree. No, 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 it's not 100, it's like 96, it's 97, something like that. Then okay, the only resolution is let's start afresh, right? Your friend who likes you comes and tells you and your teacher that something like that shouldn't happen. So any mistakes that happen here gets each term, it only resides there. So I made some mistake, didn't calculate 1 by 2, that is fine. So just clear, do 1 by 2, okay, and then do tan inverse. And I want 1 by 2, I want answer in, let's say, in degrees. Okay, so tan inverse that. So that is 26 degrees. Now I want to add this to the memory, hover it around, it's slightly changing its color, press it once, that's it. While pressing, you have some signal here and some signal there, color change there, you have to rely on it. Okay, then do ln minus ln 6. So do ln 6 and then subtract it, 6 ln. Okay, then subtract it, so I do m minus. That's it, I did it. It is log 6 to the base 5. Yeah, okay, suppose, let me rewrite that. Okay, I did till ln 6. So 3 into 2 power 4. So 3 into 2 power 4, I don't know how it will do. So let me put 2 and then do power 4. Power 4. 48. Okay, and I want to add this to the memory. I suppose, yeah, add this to the memory. Fine, I added that. Finally, 2 into log 6 to the base 5. So 2 into, just 1 second. Again, let me open a bracket with 2 expression things. 6 log 5. Okay, it's this. Okay, and then I want to subtract this, so m minus 71.76. .76. Interesting. Okay. Okay, I got one more similar answer, unless someone else, unless things are different. We'll go by that. One or two other answers, I think. We'll stop. Chat. Nilay got it. Someone else? 71.7. Fine. Nandini got it. Okay, so I suppose that is correct. Okay. So let's do a quick recap. Not here with our conventional thing. Yeah. So, you got used to gate calculator right now. So from now onwards, always use gate calculator. First of all, gate calculator makes your life easy. Some of you, some hard things looks like even scientific calculator. You don't have to write things in a paper, but you have to be slightly careful using certain things, right? That's the first thing. Where things are basic math, square root, percentage, 1 over x, and all that. This is for entered 1 by 2, instead of entering 1 by 2, enter 1 by 4. Delete button is this. Okay, all of that, all functions, this thing, mod, toggle to change this, then memory functions, and functions always work by first enter the number and then do the function. The moment you learn that, you pretty much know get calculator. Then to get familiar with it, we started doing some interesting things. Basic operations, all the things that we did in class today, trig. Yeah, The moment you do something like this when like, okay, this calculator is not all that bad. It actually kind of helps our life. You recognize that, and for denominators, always remember to use, denominators complicated expressions, always use brackets, just to be sure. And then memory, all these are most useful. This always clear this, start afresh, and then yeah, we did this. This is not all that useful. Okay, this done using save, not all that useful. But what is very very useful is this m plus and m minus, right? And be careful, multiple presses, careful. Okay, and then this is, you want to do this is like did not clear memory. Again, be very careful of that. Did not MC, memory clear. Okay, and once you know that, doing this, all of them are easy using m plus and m minus. Easy using m plus and m minus. Okay, so with that, we should also know what is not here. Functions unavailable. You can't solve equations. Many scientific calculators, you can solve equations. You can do some matrix algebra, complex numbers. Complex algebra is certainly not there. Quickly, complex numbers. So let me quickly check that. -1 square root of that. Yeah, complex numbers are not there. Complex numbers, algebra, both are not there. And then permutations and combinations you don't have, but you have factorial. Using factorial, if there is any big permutation combination, you can always find it. Okay, and any very very big number, it's going to represent it as a, in scientific notation, that is e 10 power 48, 10 power 64, e48, things like that. So big number not an issue. Okay, so use in factorial. Big number, that is any limits on how big the number is, big number not an issue, because of it uses scientific notation, not an issue. Just try it, try 10 factorial, try 50 factorial, you know what I'm saying. And finally, we already recommended this. When in doubt, use brackets, first point. Second is always remember to clear your memory. Clearing display, you'll be doing it anyways, because it's kind of cluttering, but clearing memory, it's a good practice to do that. And of course, all these are like good practices matter if you start using Get Calculator from now onwards. Start using, not even practicing, then what is good, what is bad, all those differences start mattering. So Get Calculator from now on. Okay, so with that, so let's get back to our question. We had some amazing answers. One of the biggest mistakes GATE prep students make. So we had lots and lots of answers.